What's up? I'm Alex with your daily code mentor. Today I want to talk to you about a way to build basic filtering functionality, especially when you're building a search. So when you're building a search function, your naive implementation will be, honestly, your naive implementation, so naive search will be term and possible results will be to basically return possible results map of res, and you're gonna compare them, right? So it would be a static comparison. You can do triple equal or double equal, that doesn't matter. So this will be your naive implementation of search, right? Where you simply, and we can do it as an arrow function that returns. So you will return an array of the terms that are identical to it. Your additional layer will be to do what I show here, the compare strings, where you compare and you see if the first string, which will be the term, contains the second string, the possible result. So actually this looks wrong. This will be res. There you go. So better search will be very similar. It's going to be equal to term and possible results. And it's gonna. And the reason why you put both the results and the term is that way you can test stuff. You can build tests super easily like this. So we're gonna do again possible results dot map res, and this time we're gonna return a compare strings of res and term. All right, and this means that res, if res includes term, then we return it, which will work for things like chow, and then if you have a string called CE, then it will work, or even EA, or even O, it would work for all of them, okay? But this wouldn't include spaces. It wouldn't work for strings that have spaces or multiple terms, and at the same time, it's not that flexible. So the next step is actually quite a big step. So this is okay. This will be your acceptable solution, okay? This is not bad, but your better solution is a little more complicated. And as you can see, and we can turn this into a function. We could call it function compare. Compare. So what are we gonna do? Data. So data would be the possible data, and then the other one would be string. We're gonna have string and data, and I call it function just to call it function. You can most likely because that way you can bind this, but you can also just call it const compare. You know what I mean? That's beyond the point, I guess. I just like to build my arrow function because they're cool. Okay, so and then you're gonna return your filtered. So let's analyze this before jumping to conclusion. Okay, so we got our string here, the input string, and we're gonna split it by spaces. So that way we turn A, B, C, we turn it into an array of A, comma, B, comma, C. Okay, that's why we do this. And then we have a method called compare strings, right? And then we have a method called isInSubstring, okay? And finally, we have our actual comparison. The way our comparison works is our filter results are equal on data, which is the whole data. We're gonna filter it by calling result. We're gonna filter on the results. So this will be one of them, okay? And we're gonna ask ourselves if the single piece inside of our data is in the substring, or contains the old strings, one of the old strings. So the way we're gonna call isInSubstring is basically it's gonna be a for each in which we have an accumulator that will determine whether it's there or not, and we're gonna return the accumulator. And again, we're gonna have another loop in which we're gonna loop over all of the possible strings, over all strings, over our array, and we're gonna just run the comparison again. So basically, we're gonna do a double for each. It will be a for x, for y, double for loop basically. And that way we're comparing all the possible strings, right? All the strings with all the possible data pieces, and we're doing it in a way that looks fairly nice and looks fairly elegant. And this may be very terrible if you're gonna use a long set of data. But for decently small data sets, this is one of the best solutions you can use before getting into distance algorithms that distance you between strings. I guess if you wanted to optimize this for performance, let's say you wanted to limit it and additionally you wanted to make it faster, what would you do? You most likely would have a counter, so you return as soon as you reach the limit, so you stop there. And additionally you will probably sort beforehand, and you will start the search in a good place. You know, you would probably use binary search on sorted array to reduce number of comparisons, right? And then just return. And as soon as you have enough results. Now, as you can see, to go from the naive search, which is like one line, to better search, which is basically 2 or 3 lines, to filters, which is like 20, 30 lines, I can guarantee that if you want to come to this, it's going to be probably at 300 lines. I'm saying it's actually very straightforward if you took computer science, but if you got this far, you should be proud of yourself. And this will be a great search that solves most use cases for normal user application. Let's call them user websites with around 100 items. This is as good as you have to do it. You can spend more time on it, but I wouldn't. I don't see the point. That said, if you need help in search, JavaScript, WordPress, or you just want to say hello, come hang out with me on codementor.io/Alessandro Valerani. I almost reached 100 reviews. Every single review is 5 stars. I love this job, so I'm gonna hang out for a while, and I'll see you soon. Have an amazing day.